Okay. So we are talking about regression, right? And this is what we have done so far. We spoke about simple linear regression. Okay. There we saw that we have one X variable, one independent variable or one feature. You call them X, independent variable or feature. Okay. And then when you have one Y, right? One target variable, then we apply simple linear regression. Okay. Then this is what we did. Okay. Then we went to this is how to evaluate the model, right? We discussed this. Then we discussed about all these values that OLS gave us, right? So OLS summary is another way of calculating different metric. Okay. So after we were done with simple linear, we went to multiple linear. In multiple linear, we took a data set which had multiple target variables, right? Sorry, multiple features, right? Target variable will always be one. So you have multiple features here. So, okay, so this is what we worked on. Okay. So after multiple, then we also decided how do we decide, okay, how many
भगवान
columns.
आलस है पूरा जिंदा मैं क्या कर सकता हूँ
So we also discussed about, okay, how to choose different variables or your different features, right? One way is that you select all, but all may not be impacting your analysis. Some of them could be non-impacting columns. So, so we discussed about one option where you select all. Then we spoke about backward elimination and forward selection. Elimination, you take all and you keep removing one by one to see which is, look at the p-value, right? Based on the p-value, we keep removing one by one, right? Very straightforward. This is what we did. Or forward selection is you start with one and then you add another one, then another one, so so it's all about trying with multiple columns and see which is giving you better R square and RMSE, right? And ultimately we select those set of values for our analysis. So these are this is what we did earlier. Okay, and we used OLS summary again, right? Very similar to what it's written here. Then we discussed about the factors which you have to take in account while selecting features. Okay, there should not be any correlation within the features. Okay, so okay, and there are a few other things which you can read, but those it's called multicollinearity. This is what is important. You should not have multicollinearity. Collinearity means within your feature there should not be correlation, but these values should have correlation with y. That's the point number one, right? Your x should correlate to y. Only then it makes sense to do regression. Okay, then we started talking about polynomial regression, right? And here we did a curve which was which has degree, right? Power, x square, x cube. Linear will have x degree of 1, but polynomial will have multiple degrees, right? So we saw that linear regression is not fitting well with the data, and that's where we came up with the idea of polynomial regression, right? And with change in your degree, your fitting curve will also change. Okay. Then yesterday we were talking about support vector machine. So we said that support vector machine is actually designed for classification, and we are modifying it for use in regression. So actual concept in classification is that to find this plane, right? To find this plane and okay, so just like regression line, you can have multiple line, infinite line. Here also you can have multiple planes, right? But the plane which gives you maximum margin. Margin is the distance between two endpoints of this plane, right? So the highest, biggest margin is the objective of SVC classification, and this middle line is the classifier. In our case, in regression, okay, it's reverse, right? So we still have to find, okay, the plane, okay, but our plane will be the lowest. Objective here in regression is to find the lowest plane, which will have all values in it, okay? So, okay, for example, if you talk about this, these are the, this is the regression point, right? Correlation point, and we are finding this hyperplane, which will encompass all the data within this hyperplane, right? And of course, this is plane, and your midline is called hyperplane, right? And why it's called support? Because the plane has to be supported. Okay, so in regression, the points are being, I mean, this plane is being supported by points from inside, and in case of classification, points are you have points here, the values, data points, which is supporting this plane, right? These are called support vectors. The point which is on the plane are called support vectors. Okay, so far this is what we have done, and this is the algorithm that we did yesterday, and this will have different kernel, right? So okay, we spoke about three types of kernel, right? We spoke about linear, polynomial, poly, and RBF. Okay, linear is again straight line, poly is again a polynomial kind of regression you are doing. Okay, the shape of that plane is dictated by the kernel that you use. Okay, linear value will have a straight straight line plane, right? Something like this. Okay, but you can have, okay, something like this as well. Okay, and that RBF will dictate, and we said that RBF has two factors, C and gamma, which dictates the shape of the curve. You can have a circle also, something like this. So we will discuss this more about the shape of the curve, C and gamma value in classification. And in classification, when we do, we will visualize the data and we'll see. Okay. Now today our topic is decision tree. Have you all, anybody used decision tree before? Not in terms of algorithms, but general. It's a management tool as well, decision tree. Okay. So see, the objective of decision tree is to build a tree structure. Okay, decision tree structure. So let's say this is your data. Data is not quite visible, but it's not even bad also, right? Like Outlook, you have rainy, rainy, overcast, sunny, 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 overcast, temperature, hot, hot, mild, cool, right? And then humidity, you have high, normal, and probably you'll have low also somewhere. And windy is false, true, false, false, right? True, false. And then this is target variable, hours played. Okay, so let's say, it could be cricket match or any sports. So based on the weather forecast, you want to predict how long the matches will be played. Okay, so you have in this case, it's easier to talk up, work with categorical value, but we'll see later that we can use numerical value also. But let's understand first the concept of decision tree using this, and then we will talk about the how to use numbers. Okay, of course we will use numbers. So um, decision tree, okay, is created based on your training data. Okay, so when you say fit, right, model.fit, it creates a decision tree. Okay, and in the decision tree you have again this is again another classification model. Okay, so decision tree was mostly, okay, it was designed for classification, and we are modifying it for regression use. Okay, so what it is, what this is, okay, based on the data point, okay, you first create a tree. Okay, so let's start with this. Okay, now you can start with any column. So let me move to paint. Okay. Now, let's say I start with mm, one that has, okay, let's say Outlook only. Okay, first column is Outlook. So I'm writing Outlook here. And Outlook has three possible values. Okay, overcast, sunny, and rainy. Overcast, sunny, and say rainy. Okay.
Recording in progress.
So these are your three different values for Outlook. Okay, there are three different values for Outlook. Okay. Now let's add temperature to it. Anything you can add. Okay. You add temperature to it. Okay. So so temperature. Now your temperature value, it says cool, mild, and hot. So cool, mild, and hot. Here also you can add cold, mild, and hot. Okay. Now here you can use something else. Okay. What else? Humidity. High, normal. I don't see low value here. Okay. So you have high and normal. So rainy, humidity I'm adding high and normal. Now, which one to take, which one to, so it is, the decision tree, okay, randomly creates these values, okay. So, you end up creating, uh, if you see, we can have many number of decision trees here, okay. You start with Outlook and include, temperature here, humidity here. You start with humidity and, okay, so it doesn't matter, okay. You end up creating these values. Now what we do is, from the data set, we look at if it is over, let's say we stop at level 2 only. We are not going to level 3. We can go to level 3 and 4 because we have 4 variables, isn't it? So you can go to level 4 as well. But let's say I stop here. So here, the situation that you have seeing is it is overcast and cool. Okay, overcast and cool. Now you go to your data set. Okay. Similarly, you can have level 3 and level 4 also. Okay. For explanation, I'm just using level 2. Now you go to the data set. Okay, the first condition that we have identified from decision tree is overcast and is it cool or hot? Cool, right? Overcast and cool. So you look at overcast, okay? Temperature is hot, okay? So ignore this. Overcast, cool, right? Overcast. So overcast, cool is only one value, 43. That means, okay, if it is overcast and whether the temperature is cool, then you have 43 hours of match played. Okay, so we'll go to, I'm not sharing it, I'll show you later. I'm just writing 43, okay, against overcast and cool. Next one you have is overcast and mild. So overcast, hot, no. Overcast, cool, no. Overcast, mild. So overcast, mild is 62 hours. So we'll go and write 62 here. Okay. Next is overcast and hot. So you see, overcast and hot, 46, let's say. Overcast and hot, 46. Do we have any more? Okay, overcast and hot, 44. So here you have two values. Then you take average of these two values. So that means when it is overcast and hot, you have matches like 46, 44. So average of 46 and 44 is what, 90? And 90 by 2 is 45. So average is 45. So I go back and I write this here as 45. Okay. This is how your decision tree works. decision tree work. Now, decision tree is called as weak algorithm. We'll again, once we do classification, we'll come back and we'll talk about strong, weak, and different types of algorithms and how we can make it even more strong. This is weak, so I can make it strong. So, okay, the next algorithm that we're going to talk about today is called random forest, and random forest is way to make this algorithm, the decision tree, even more stronger. So we'll talk about it. Okay. So first, look at this. Did you understand this? So objective here is to create these decision trees. Okay. Similarly, you can have sunny and cool. Let's say you have some value here, sunny and mild. Sunny and this. Now rainy and hot or high. Sorry, this is high. Humidity is high. Sunny and high and sunny and normal, you'll have some values. Now this is, okay, of course, when you have more than one value, you take average of all those values that falls under that pattern. Now if you have to predict, okay, now let's say new value comes in, okay, which says that outlook is rainy, temperature is hot, humidity is normal. Humidity is normal. Okay. Overcast, high temperature, humidity. Now you tell me which decision tree will be chosen. So it says overcast, right? We start with outlook. So outlook overcast. Sorry, no, outlook is rainy. O is for outlook, right? So outlook is rainy. That means outlook rainy goes here, right? Now output rainy, it does not take temperature into account. Okay, one of this decision tree does not take temperature, so this is not important. That means, okay, what decision tree is saying that whether it is hot or mild or cool doesn't impact. Okay, so now you look at humidity. Humidity is normal. That means you go here. This is the decision tree that I'm looking at. And if this value is 29, then you will predict 29. Your prediction will be 29. Simple? Yes or no?
Awesome.
Right? This is called your decision tree algorithm. Okay, so decision tree algorithm is about finding those decision trees. Okay, find those decision trees and then use the decision trees to make prediction. Use that decision tree to make prediction. Okay, so we are making prediction using decision trees, and you can create different numbers of decision trees. Now, this is when you have categorical value. Okay, what if you have numerical value, right? So let me go back to our notes. Okay, so this is what I just did. Okay, we create. So this is another type of decision tree that we can create. Outlook, sunny, overcast, rainy. Then sunny, we took windy. Windy is true or false. And if it is sunny and false, windy, false, this is the average value of all the data from this table. Okay, this is the average value. Okay, overcast, I stop at overcast only. So 46.3 is the average value here. Okay, and this is how you calculate. Now, you tell me the set of input values and will be able to predict. So prediction will be based on the average that is created here. Okay. So this is your decision tree. Okay. So now coming to the numerical value. Okay. So this is the numerical value. Now let's say this on x-axis you have age. So let me take this to paint and then we can use it. Okay, so let's say you have age on x-axis. You have age on x-axis and you have salary on y-axis. Okay, so this red plus sign that you see, these are your the training data, right? So it says that, okay, if age is 48, salary is well, like let's say 50,000. Okay, so you have got this. Okay, this is another value here. If age is 48, salary is let's say 3 lakhs. So these are different values. Okay, so each of this point is representing value on age and salary, the training data, right? Now it says, okay, you start dividing this into groups. So I start with, let's say, age here. I start with age. Now I divide, okay, so if you look at your decision tree here, this is how it looks, okay? Now you start with, okay, so let's say we start with x equal to 20, okay? So I'll say x greater than 20, let's say. So is x greater than 20, you'll have two values. Is x greater than 20, you will have yes and no. So let's put no first and then yes. No, yes. So no is this side. So let's say I started with x, okay, and this is y, right? Or x1, x2. We don't call y because y is a prediction, right? So we don't want to predict. We will start with here. So now when you say x, so I'm dividing this data into, this is your first split, right? So this is first split and you can take any number, okay? It will not be 20, you can take 30 also. I took 20. Now, no and yes. So that means when you say no, when you divide this into at 20, this is your no value and greater than 20, right? So this is your no and this is yes, correct? This entire thing is yes. Now, I can say x less than 20 also. If I say x less than 20, then this will be yes and this will be no, correct? Okay. Once you take value on x1, next you have to take different value. You cannot take again x1. So we'll take x2. Now, x2 is doing split here. See the split 2. So I'm saying x2, okay. When you say no, okay, so no is this side. So in fact, this here it is done on this side, okay, not here. Okay, so here I'm saying is x2, okay, greater than 170. Now this greater than 170 is in x greater than 20, isn't it? So split 2. So I'm just showing how this split is done. So x2 greater than 170. Yes, no. Okay, so or we'll use no first. Okay, no. You're using greater than, so I'm saying no and yes. So when I say no, okay, x2 greater than 170, no. So no is all these area, correct? This is your no area and this is your yes area. Okay, so done. Now split 3 is done on this side. So x1, so I have to say I'll take x2 here. Now x2, okay, greater than 200. Okay, let's say 200 is it is 200k, so 2 lakh. Okay, then you end up creating again no and yes. Okay, no and yes. No will be this side, yes will be this side. So this is your split 3. Okay, then you have split 4. Split 4 is at, okay, greater than 20 this side and less than 170. So this one, this is where we are doing. Now since we have done x1, x2, and now we'll do x1 again, alternate. Okay, you are doing x1 and this is x1 greater than 40 you are doing. So this is your decision tree. And end of every decision, let's say here we have only 4 split, right? This is 4 split is done. And average of this. So See, here if you see x greater than 20 and x2 greater than 200. X greater than 20 is all this, and x2 greater than 20, 200 is this part, right? So you take the average, calculate the average, and that will be the value here. So each of this, okay, this is one split, this is another, right? So you end up calculating 1, 2, 3, 4, 5 split, right? 1, 2, 3, 4, and 5 split, right? You have 5 split. Okay. Now these 5, okay, will have the average value because it's a regression, right? You will have some numerical value at the end. So take the average of the numerical value. So in this, say, average is 300. Here, average is 65. Average is minus 64. Average is 0.7. Average is 1023. Okay. So once you created decision tree, okay, now, okay, let me ask, this is when you give me training data, dot fit using when you say train the data, this is what algorithm will create. It will create a structure, tree structure like this. Now I say, okay, you ask me any question, I will be able to predict what you want. Okay, you say, okay, if the salary is 38 and if the age is 38, salary is, let's say, 1.8 lakhs, what is the value? Okay, so salary is 38, that means here, and 1.78 or something, that means here. So 38 and 1.7 falls in this region. So the answer is 1023. So this value will be predicted for you. Understood how it works?
Yes.
And you can have a numerical and categorical. Okay, categorical will be, let's say, 2 values or 3 values. Let's say temperature, for example. Okay, so you can have hot somewhere here, mild here, and cool here, right? So you will have 3 boxes coming from x2, and numerical will have, again, you can decide where to put. Okay, and the average of those values will be stored as the solution. So depending upon your question, it will see, okay, so which path are you following? Question is following this path. So this will be the answer. Question is following this path. So this will be your predict value. Is it clear?
Yeah.
Okay. So this is how your decision tree algorithms work. Now, decision tree is weak algorithm in the sense, it's not as strongly classifying or giving you the regression value as the SVM or multiple linear or linear values that we have, the algorithm that we have seen. So what we do is sometimes, okay, calculating multiple vehicle algorithms will also give you better result. So decision tree in itself is it's not very accurate. But what we do is we create something called as random forest. What is tree and forest? Forest will have multiple trees, isn't it? So what decision tree is saying, you create multiple trees. Okay, and when you are writing this parameter for decision tree, random forest, you can say n trees, number of trees equal to 500, 400, 200, 900. So random forest will create different sets of trees, 500 sets of trees. Okay, so let's say this is tree 1 and you create a different way. You started with dividing at 10 only. So you'll have different tree, right? So like that, random forest will create multiple trees. Okay, and if I ask to predict, so let's say tree 1 is giving 120 and tree 2 is giving 300, tree 3 is giving 280 as prediction value. You'll have 5 trees, so 5 values will come. And again, you take the average of those 5 values. Okay, it's like this, okay? Teacher give you an assignment to all of us. Let's say there's some assignment, mathematical assignment, okay? And all of us got different answers. So what do? We take average of all our answer and then we say, oh, this is the answer. Something like that, okay? This is what random forest is doing. Creating multiple trees and taking, see, decision tree itself is about taking average of this each block, right? And it will give you one answer. And then random forest will take all these values, calculate average of the output from each of the tree, and that becomes the final answer. And in fact, random forest gives you better accuracy, sometimes even better than SVM and linear regression. So this is how decision tree and random forest works. So we just covered two algorithms. Okay, decision tree is one, and running multiple decision trees is random forest. Clear? Any questions so far? No, yes, maybe.
No, sir.
Okay, so yes, so now we have to run this algorithm and check. Okay, so we can take same startup data. Okay, so I do not have the link. Let me create. We'll now see how to build it. Okay, how to build these algorithms. Then get this startup. Same data that we use for multiple linear, we'll use even for this. So key here is to build the decision tree, okay, based on the training data. Oops, I think it's not able to read it. We're talking about decision tree and random forest. Okay, so of course we'll first use the import. So import pandas as PD. Okay, and I'm going to say link. Okay, if this doesn't work, then I'll have to use, yeah, this link is not working. Okay, sometimes it works, sometimes it doesn't matter. So instead I'll take my local link. Okay, I'll say link equal to, I'll go and let me see this. It's in D data set the underscore startups. Okay, slash. Okay, so this is the data set. So I'm going to say df equal to pd dot read CSV, and we'll give the link here. Okay, so data set is now ready. If you want to print df, you can print it. Okay, so we have to divide it, right? So let's say we ignore state. Okay, we ignore state. Okay, I'm doing just for faster calculation, right? Because if I take state, I'll have to do categorical, right? But you should do it. Okay, you do it for all the values. Okay, I'm taking it simply, say 2 columns or 1 column, whatever, right? So because just to save time. Okay, but you know how to convert data into categorical, right? So you should take, okay, you should take all the columns and try. Okay, 1 second. Okay, so x equal to your df okay, dot ilog all rows, okay, and you should be saying 0, 1, okay. I mean, you should be saying like 0, 1, 2, 3. So put 4, right? Dot values. But for faster, okay, doing and seeing the result, I'm not going to read all the 4. I'll just read maybe 2 or 1 or whatever, right? Then y is obviously your last column, right? So this is your ilog all rows minus 1. Okay, so last column, right? Okay. Now we will divide this into training and test set. So I'm going to say from sklearn dot model selection import train test split. Okay, and I'm going to say x train comma x test comma y train comma y test equal to train test split, and then you provide x and you provide y, then you provide the test size. Okay, I'm going to say 25%. Okay, and then if you want to give random state, you can give random state. Okay, so that you can actually compare the value every time. Okay, it's going to come same. Your answer and my answer will also come same if you fix the random state. Okay, so this is the minimum pre-processing step that you have to done. Now let's call decision tree. So you have from sklearn dot tree you have decision tree. So I'm going to say from this import decision tree. What should you do? Regressor or classifier? Which one should I call? Should I use decision tree classifier or decision tree regressor?
Regression.
Regressor. Yeah.
Regressor.
I don't know why you're.
I don't know why you're.
That's it. So it will randomly create its decision trees. Okay. Now we have to fit it, right? So regressor dot fit, and here you provide your training data, X train and Y train. So based on X train and Y train, it will create decision trees. And now if you want to predict, you can predict, okay, equal to regressor dot predict, and you give your X test value. That's it. Done. Now, of course, you can create your R square RMSE for both training and test, right? And you can compare. And I want you to do this comparison. I'm going to stop it here, okay? And I want you to continue here, evaluation. Okay. Now, how do you build random forest? Okay, so I want to show you how to build random forest. So random forest is part of something called as ensemble. Okay, so again, there's concept called as bagging, boosting, ensemble. Okay, so these are like running multiple algorithms. Okay, so when you have to run multiple algorithms. Okay, so ensemble step says that run same model multiple times. Okay, if I'm running decision tree, so run decision trees multiple times and take the output and find the average. That is called ensemble. So bagging and ensemble are very similar. Bagging also does same thing. Okay, you run multiple algorithm, you take the output from multiple algorithm and find average and give the average. But ensemble here, okay, means you have to run same algorithm. If you're talking about decision tree, you have to run decision tree only. If you want to run SVM, you have to run SVM only. SVM only you run, and it will find the multiple as SVM with multiple, let's say, kernel value, run and find the average. Bagging, you can run different algorithm. I can run SVM, I can run decision tree, I can run multiple linear, and find the average of all the algorithms and give the output. That is called bagging. Bagging and ensemble, very similar. Multiple algorithm, output, average, and give one value. Boosting is different. In boosting, what we do, we run one algorithm, we take the output of that algorithm, then you, based on the training data, you say that which parameter, for which values, you are confident about answer. Let's, for example, in decision tree itself, let's say you come up with 5 decisions that we created before, right? You say that, okay, based on the training data, accuracy of, or accuracy in the sense, RMSE in regression and accuracy in classification. You say that out of these 5, okay, let me go back to Paint and then I'll talk about it. So let's say you are here. Okay, so you'll have your average value, and then you compare with each of the values. You find that this has the lowest error, lowest RMSE, highest R square. So you say that I have created this decision tree. Okay, I have created this 5 split, but out of this 5 split, this is giving me very high accurate. Okay, so I am very confident about this, but I'm not so confident about other 4. Now, bagging, what happens? You are running again you're creating another decision tree. And these output will go to decision tree. Now, this one will be left as it is, because here you are getting very good accuracy. So this will not be touched or maybe slightly changed, but more focus will be on improving the accuracy from other 4 split. So it's like this. Okay, let's say you are 6 of you and I give an assignment, 6 questions. So one option is that what I told you, ensemble and bagging, is all of you do the assignment, and then you see that your answers are different. So you take average of all your answer and give one answer, saying that, okay, this is what we think is the answer. That is your ensemble or bagging. Okay, bagging, different algorithm, ensemble, same algorithm. That's the difference between them, but the concept is same. You take average and give one value. Boosting is like one of you will make an attempt of solving all the 6 problems. And you say that I am confident about question number 1 to the second one. Okay, you say that I'm confident about first solution, but I'm not confident about other 5 solution. So the second person who takes from you will just verify the first problem, will spend very little time on the first problem, but they will, he or she will attempt to solve other 4 problems, other 5 problems. Next, when that person is done, then he'll give it to the third person, saying, first one said that he is very sure about first problem. I am very sure about third solution. Okay, so you take care of second, 4, and 5. Okay, so you will see, it's not that you will ignore it totally. Okay, you will see first and 3, but you will not spend more time because you already got a feedback that your first and third solution, their person is very confident about it. So you will try to solve 5, second, 4, and 5. So what happens after you go through multiple iteration? Okay, we expect that the final output that you give will be of very high quality. This is what boosting does. Okay, and we'll talk about towards the end what is different types of boosting, ADA boosting and bagging also, we'll talk about it. But now, random forest is a type of ensemble algorithm. Okay, ensemble means you're running multiple decision trees, getting the output and giving average of all the decision trees. So here, okay, there's a library called ensemble here. So from sklearn dot ensemble, okay, import random forest regressor. Okay, and when you create this random forest regressor, you have to, okay, mention number of estimators. this how many trees you want to create. I say I want to create 10 because data set is very small, right? But when you have lakhs of rows, you can create even 500,000 rows. I'm saying create 10 random forest. That's it. Then after that, it's exactly the same. You fit and you predict. So assignment, complete this, these, right? Algorithms and check the RMSE and R square values for both of these algorithms, right? Might look very simple, but again, this is very powerful algorithm. Did you understand? Are we good?
Yes, sir.
Yes.
Yes. So try to complete it. And if you have any questions, you ask me tomorrow. Okay. Tomorrow we are going to do what is called a Rees lasso elastic net algorithm. Okay. With that, we'll finish off regression, and then day after we'll move to classification. Okay.